What if Earth collided with another planet? Imagine a day when a Mars-sized planet is set on a collision course with Earth. At first, it's not chaos, but numbers. Telescopes detect it long in advance. News spreads across the globe faster than light through fiber optics. Scientists refine the data. Mass similar to Mars, velocity immense, impact probability rising. Governments launch emergency programs, underground bunkers, interceptor missions, desperate plans. But changing the path of a planet requires energy beyond anything we can produce. As it approaches, gravity pulls Earth's oceans into massive tidal bulges. Satellites wobble, orbits decay, communications sputter and fail. Earth's crust groans. Earthquakes intensify, volcanoes erupt. The atmosphere heats from shockwaves and incoming debris. People look up. The second planet is now visible in broad daylight. Supercomputers model the outcome, an energy release of 10 to the 32nd joules, greater than all volcanic eruptions and nuclear weapons combined. The gravitational embrace distorts both planets into tidal bulges. Magnetic fields collide. Auroras flare even in the tropics. Impact begins. A shockwave races through the mantle faster than rock can carry sound. Continents vaporize instantly. Cities erased in a flash. Oceans turn to steam. The sky becomes a furnace of white fire. Streams of molten rock blast into space. Gravity whirls the debris into a giant disk around the wreckage. The iron cores merge, sinking to form a shared, blazing heart. Silicate vapors create a temporary atmosphere of stone gas. Parts of the disk cool and clump into massive chunks. This is how scientists believe our moon was born, when Earth collided with Theia. A new collision could create another moon, or perhaps a ring system. But the orbit might shift, sending Earth closer to the Sun. Or outward, into the frozen void of deep space. For life, the outcome is the same. Extinction of all complex forms, survival only for microbes. For years after, a sea of magma would boil beneath a thin, rocky crust. Stone and metal rains fall back, smoothing the planet. Radioactive decay and residual heat keep the world molten for hundreds of thousands of years. If the disk stabilizes, a new moon could form, helping anchor the axis. Over time, the crust cools and new geology begins. Water could return from within the mantle or from icy comets. The atmosphere rebuilds, with clouds and storms taking shape. Life, if lucky, might begin again, just as it once did on Earth. But for us, modern humans, collision means an end, not a rebirth. That's why we watch the skies, track near-Earth objects, and study orbital mechanics. We cannot stop a planet, but we can defend against smaller cosmic threats. In the universe, destruction and creation are two sides of the same process. If Earth collided with another planet, it would be the end of our story. But perhaps the beginning of a new one, for a molten world and its newborn moon. The vast and cold logic of the cosmos reminds us, we are just a brief but shining chapter.